The F-test is an essential statistical tool used to compare variances between groups and test the significance of multiple group means simultaneously. It is frequently applied in educational research and management to evaluate differences across various classes, programs, or instructional methods. While the t-test is ideal for comparing two means, the F-test is valuable when there are three or more groups or factors, providing a broader and more detailed analysis. Main types of F-tests and guidance on when to use each. 1. One-way ANOVA, analysis of variance. Use when you want to compare the means of three or more independent groups on a single factor or variable. Example: an education researcher wants to test if different teaching methods, e.g., lecture-based, interactive, and blended, lead to different student performance levels. A one-way ANOVA will test if there is a statistically significant difference between the groups. Interpretation: if the F-test reveals a significant difference, it means at least one group differs from the others, although it won't specify which. Post hoc tests are needed to identify where specific differences lie. 2. Two-way ANOVA. Use when you want to examine the effect of two independent variables on a single dependent variable, and also explore any interaction between these two factors. Example: suppose an educational manager wants to analyze both the effect of teaching method, traditional versus digital, and class size, small, medium, large, on student performance. A two-way ANOVA can assess both factors individually and also reveal if there's an interaction effect, i.e., whether the effectiveness of a teaching method depends on class size. Interpretation: if the F-test for interaction is significant, it suggests that the two factors interact, meaning the effect of one factor depends on the level of the other factor. 3. Repeated measures ANOVA. Use when you want to test the same group of subjects under different conditions or over time. Example: an educator measures student test scores before, during, and after implementing a new curriculum. Since the same students are being measured multiple times, repeated measures ANOVA is appropriate. Interpretation: a significant F-test result would indicate that there is a difference in test scores across the time points or conditions. Further tests can identify at which time points these changes occur. 4. ANOVA, analysis of covariance. Use when you want to compare group means while controlling for one or more covariates, continuous variables that could influence the dependent variable. Example: an administrator compares student performance across different schools while controlling for socioeconomic status, SES, as a covariate. ANOVA adjusts the performance scores to account for SES differences, allowing for a more precise comparison of school performance. Interpretation: a significant F-test result indicates that differences exist between groups even after controlling for the covariate. 5. MANOVA, multivariate analysis of variance. Use when you have multiple dependent variables and want to test group differences across all these variables simultaneously. Example: if an educational researcher wants to see if teaching methods affect both student grades and engagement levels, MANOVA can assess these two outcomes together, providing a comprehensive view of group effects across multiple dimensions. Interpretation: a significant F-test in MANOVA suggests differences among groups across the combination of dependent variables. Post hoc tests can help identify which variables contribute to the differences. 6. F-test for equality of variances, Levine's test. Use when you need to test if two or more groups have similar variances, which is often a prerequisite for other statistical tests. Example: before running a t-test to compare two groups, you could use Levine's test to ensure that the variances of the two groups are equal, as this is an assumption of the t-test. Interpretation: if the F-test indicates no significant difference in variances, you can proceed with a t-test or ANOVA under the assumption of equal variances. If variances are unequal, alternative statistical methods should be used. Importance of the F-test. Comparison of multiple groups. The F-test is often used in analysis of variance, ANOVA, where it tests for significant differences across multiple groups. For instance, in educational settings, it can compare the effectiveness of different teaching strategies or curriculum programs across multiple classrooms, subjects, or grade levels in a single analysis. Variance testing. The F-test helps evaluate whether different groups have similar variances. This is crucial when assuming equal variances between groups, which is often required for accurate statistical testing. For example, it can assess if the level of student performance variability is similar across different teaching methods or classroom environments. Identification of interaction effects. In more advanced applications like two-way ANOVA, the F-test allows researchers to examine interactions between different factors. In educational research, this could mean evaluating how both teaching methods and student demographics, e.g., age or background, simultaneously impact performance, providing a more nuanced understanding of educational outcomes. Decision-making in resource allocation. The F-test's ability to compare multiple group means simultaneously can guide resource allocation. For instance, it helps educational administrators identify the most effective programs or interventions by comparing the outcomes of multiple programs at once, ensuring that resources are invested in the most impactful areas. Advantages and disadvantages of the F-test. Advantages. Versatile for multiple groups, efficiently handles comparisons across 3 or more groups, making it ideal for complex educational studies. Insight into variance, provides a measure of variance differences, which is crucial for validating assumptions in data analysis. Foundation for multivariate analysis. The F-test is foundational for more complex tests like ANOVA, multivariate analysis of variance, which can analyze several dependent variables simultaneously. Disadvantages. Sensitivity to assumptions. The F-test requires the assumption of normally distributed data and equal variances across groups. Violating these assumptions can affect the accuracy of results. No indication of specific differences. The F-test only tells whether there is a significant difference among groups, not which groups specifically differ. Post hoc tests are required to identify specific group differences. Application in educational management (MEM). In educational management, the F-test is useful for evaluating the effectiveness of various interventions or strategies across multiple groups. For example, if a school district implements different math tutoring programs in different schools, the F-test can determine if there are significant differences in student performance between programs. This insight helps leaders make data-driven decisions about program implementation and scaling, ensuring that they are based on statistically validated effectiveness rather than assumption. Additionally, in teacher performance reviews, the F-test can assess if different departments or teaching strategies yield similar or different student outcomes, allowing for targeted improvements where needed.